Professor Yabe proposed the ultimate electric vehicle that runs on magnesium fuel, like a gasoline car, eliminating all the shortcomings of conventional electric vehicles and achieving decarbonization. Fuel can be bought at convenience stores, and spent fuel can be returned to convenience stores for recycling. More than 100 years after the launch of the Model T Ford in 1907, the gasoline car kingdom continues, because it takes 1–2 minutes to inject fuel, can store a large amount of fuel, has a long cruising range, can carry fuel over long distances, and can store fuel for a long time. If you reverse the advantages of gasoline cars, it will be a disadvantage of EV. The driving range with a 40 kilowatt-hour battery is about 240 kilometers. It takes 10 hours to charge it at 200 V, 20A. Charging stations can only be connected to the power plant by wires, so it is not economically viable in depopulated areas. Charging the electricity produced by coal and oil power plants will not decarbonize it. Even if we have a battery that can be charged in 1 minute, it will need 2.4 megawatts of electricity to charge one car, which is huge, corresponding to electricity for 1,200 homes. And if there is a 1-minute spike in electricity demand of 2.4 megawatts here and there, the power infrastructure will collapse. Hydrogen fuel cell vehicles are similar to gasoline vehicles, but there are problems with storing and transporting fuel. In order to store hydrogen in liquid, it is necessary to keep it at -253 degrees Celsius, and there is a problem that large containers cannot be used at high pressure, and it is expensive. The method of extracting hydrogen from natural gas, etc., eventually releases carbon dioxide. The method of transporting hydrogen in the form of storage alloys and compounds and generating hydrogen locally require electricity and energy. The ocean covers about 70% of our planet that contains huge magnesium of 1.8 quadrillion tons, which is an energy equivalent to 100,000 years of oil. It can be burned instead of oil and coal to run power plants. Even if it is burned, greenhouse gases are not generated, and the burning residue is solid, so it can be recovered. It can also be used for magnesium fuel cell. When magnesium reacts, the surface is covered with an insulating film, and the inside is unusable. Recently, a chemical that dissolves this insulating film is added to make a new surface appear, but the dissolved substance increases the resistance of the electrolyte, and the output is very low, because the electrolyte of salt water has 10 million times the resistance of copper, so if there is more electrolyte, the output will be lower. Professor Yabe thought that if magnesium was so thin there would be no problem even if the film was covered with insulator, and it would be possible to generate electricity efficiently. Then electrolyte would be less, the resistance would be reduced, and a large output would be possible. The electrolyte is soaked into a non-woven fabric, and thanks to this, the reacted magnesium can be trapped in the bag, and it can be easily recovered and recycled.
A supply of new magnesium is constantly fed into the reaction chamber where the electrodes are, and the oxidized layer is wound up. This way, power generation efficiency does not decrease, and if a large amount of magnesium is used, the energy generated also increases. This is the most important feature of our new battery that is absent in conventional magnesium batteries.
The first proposed fuel cell was a mechanism that wound up a thin film of magnesium like a camera film, and it could be stopped and resumed at any time, so it was a practical mechanism. However, with this, there is a disadvantage that the volume becomes large in order to connect a large number of batteries and increase the voltage and output. If batteries are arranged in series within a single electrolyte, a short circuit will occur, but Professor Yabe found a structure that avoided short circuit and patented it. Since such a compact battery has been realized, it is possible to output 200 watt with a small battery of about 20 centimeters. Video demonstration shows a performance of a type of battery that manually inserts 12 magnesium fuel plates and produces an output of 130 watt for drones. Experiment in which a golf cart with a 48V 3 kilowatts motor was operated with a magnesium battery. It was conducted on an actual golf course. Original 4 lead-acid batteries weighing a total of 160 kilograms were replaced with magnesium batteries, weighing 1/10. It was able to start on a slope without any problems, and was able to drive on various undulating roads of the golf course without any problems. A disc-type fuel cell is closest to practical use. The video shows a simulation of the battery operation. The pink part is the magnesium plate, the triangular pyramid part is the battery reaction chamber. Magnesium fuel enters the reaction chamber while rotating and comes out. The magnesium battery corresponding to Nissan Leaf is 24 kilograms, which is 1/10 the weight of a lithium-ion battery. The size will be about 60 centimeters in diameter and 50 centimeters in height. A small unit of about 6 kilograms is easily replaced and is inserted into the battery slot at any time. If you use 6 pieces, it will be 36 kilograms, 54 kilowatt hours. The fuel is magnesium with a thickness of about 1 millimeter, so it will not burn easily even if it is lit, so it is extremely safe and will be able to be sold at convenience stores.